How did the universe arise? What was around before that? Might there have been no beginning? Could the universe be infinitely old?
Are there boundaries to the cosmos? The current scientific story of the origin of the universe begins with an explosion which made space itself expand. About 15 billion years ago, all the matter and energy that today make up the observable universe were concentrated into a space smaller than the head of a pin. The cosmos blew apart in one inconceivably colossal explosion, the Big Bang. And the stuff of the universe, together with the fabric of space itself, began expanding in all directions as they do today.
We have a pretty good understanding of the history of the universe from 1/100th of a second after the Big Bang until today, 15 billion years later. And it's pretty remarkable that I can say this, and it's even more remarkable I can say it and the men in white coats don't come and pull me off the stage. And I think that part of the history we have pretty much nailed down, because there are fossils and relics that are left behind that tell us that our theory is right.
Let's imagine that each of the windows in the lighthouse looked out on an earlier epoch in cosmic history, so that this first window let us see the way the universe looked when it was only 1 billion years old, and that each step up the stairway from there on took us back to when the universe was 1/10 its previous age, to only 100 million years after the Big Bang, then 10 million, 1 million, and so forth. Walking in this way, we very soon would have reached the first second of time. And that's important because a lot happened during that first second. We're climbing now into very early times. When the universe was 1 second old, the heat was so intense that it overwhelmed even the strong nuclear force. That's the force that holds quarks together to make protons and neutrons. From here on up, even such fundamental structures as protons and neutrons can't exist. The universe is a soup of free quarks. 1/10th of a second, 100th of a second after the beginning of time, the universe now is so dense that even neutrinos, subatomic particles so aloof that they can normally fly through a trillion-mile block of solid lead without hitting anything, even neutrinos are now bound up in the universal broth of matter and energy. We've reached the first instant of time. The fraction of a second that has elapsed since the universe began to expand is so small that it has no name. To express it, you'd have to write a decimal point and then a string of 40-some-odd zeros. The universe, everything that there is or can be, was contained, we think, at this point within a single spark of energy, rapidly expanding, but still smaller than the nucleus of an atom, and ruled by a single primordial law. If we knew what went on at this epoch, we might finally understand the relationship between the laws of nature and between space and time and matter and energy. But we don't yet know. We lack a theory that can explain how nature would have behaved under these extreme circumstances. A lot of people are looking for such a theory. Some think it'll be a kind of quantum gravity, or what's called a superunified theory, or a supersymmetry theory. And of course, we don't know what the theory will say. But whoever hits upon that theory will be the first to have glimpsed the very threshold of creation.
Probably the most fundamental question that we can ask about the universe is, what got it started? Where did it come from? The moment of creation. And that's probably the most difficult thing to try to answer. Because in cosmology, the way we reconstruct the history of the universe is to run the movie backwards. The way we run the movie backwards is by using the laws of physics. The laws of physics that we presently know are probably good enough to take us back to within 10 to the minus 43 seconds of the bang, or the moment of creation. That's pretty close. But in order to go all the way back, we've got to get a better theory of gravity. We need a quantum theory of gravity. And I suspect that we may always find ourselves in this position, that to go that last tiny fraction of a second, we need some knowledge that we don't have. And so I think it may be a very long time, if ever, before we can answer the question that everyone would like to know. What caused creation?
If the general picture of a Big Bang followed by an expanding universe is correct, what happened before that? Was the universe devoid of all matter and then the matter suddenly somehow created? How did that happen? In many cultures, the customary answer is that a god or gods created the universe out of nothing. But if we wish to pursue this question courageously, we must, of course, ask the next question. Where did God come from? If we decide that this is an unanswerable question, why not save a step and conclude that the origin of the universe is an unanswerable question? Or, if we say that God always existed, why not save a step and conclude that the universe always existed, that there's no need for a creation, it was always here? These are not easy questions. Cosmology brings us face to face with the deepest mysteries, with questions that were once treated only in religion and myth.
Broken Symmetry, a Robert Wilson sculpture, expresses one of the beliefs of modern physics, that the universe may have begun in a state of perfect symmetry. The theories say that matter froze out of energy while the early universe was expanding and cooling, that form arose from formlessness, like ice crystals congealing in a freezing pond. Perfect symmetry may be beautiful, but it's also sterile. Perfectly symmetrical space means nothingness. As soon as you introduce an object into that space, you break the symmetry, creating a sense of location. There's a place where the object is and other places where it isn't. And out of that comes tumbling all of the geometry of space as we know it. Perfectly symmetrical time means that nothing can happen. As soon as you have an event, then you break the symmetry and time begins to flow in a given direction. We live in a universe that's full of objects and events, and that means that the universe is imperfect and that the symmetries in the universe we live in are broken. It may even be that we owe the very origin of our universe to the imperfection of the breaking of the absolute symmetry of absolute emptiness. There's even a theory to this effect. It's called vacuum genesis, and it suggests that the universe began as a single particle arising from an absolute vacuum. Curious as it may seem, this idea violates none of the known laws of physics. We've seen how virtual particles come into existence all the time from a vacuum and then fall back into non-existence. There appears to be no upper limit on the size or longevity of the particles that can be created in this way. It's just possible that there might have been absolutely nothing, out of which came a particle so potent that it could blossom into the entire universe. It's not very likely, but then it only had to happen once. The theory of vacuum genesis is a new idea, and nobody knows whether or not it's true, but it does satisfy two of the criteria of a sound scientific theory. It seems at first so strange that it must be preposterous, and like the universe itself, the longer you get to know it, the more beautiful it becomes.
We haven't come to the bottom level yet, but as we approach it, we pick up intimations of an underlying beautiful theory, whose beauty we can only dimly see at the present time. We don't know that it's true. We don't know there really is a beautiful underlying theory. We don't know that as a species we're smart enough to learn what it is. But we do know that if we don't assume there is a beautiful underlying theory and assume that we're smart enough to learn what it is, we never will.
The expansion of the universe was predicted by Einstein's general theory of relativity, published in 1915. But the idea seemed so outlandish that Einstein himself rejected it. He introduced an extraneous term into the field equations to try to make his theoretical universe stand still. Then, in 1929, the American astronomer Edwin Hubble, without knowing of the relativity prediction, discovered that the universe is indeed expanding. Astronomer Alan Sandage, once Hubble's pupil, has devoted much of his career to studying the expansion of the universe.
It is not as if these galaxies are expanding into a space that's already there. The view is that the space itself is expanding, carrying the galaxies with it. The expansion creates the space. It's, well, the crucial analogy first made by Eddington as long ago as 1930, just 1 year after Hubble had announced the expansion, was you can conceptualize the thing as the two-dimensional analog by the surface of a balloon. You paint dots on the surface of a balloon and you blow it up. You put yourself on any dot, you seem to be the center, and all the other dots move away from you.
Imagine this universe is expanding. If we blow it up like a four-dimensional balloon, what happens? An astronomer in a given galaxy thinks all the other galaxies are running away from him. The more distant the galaxy, the faster it seems to be moving. This is just what Humason and Hubble found. On the surface of this curved universe, there is no boundary or center. The universe can be both finite and unbounded.
Now, take the air out of the balloon and look what the dots do. All the dots come toward every other dot, and if you could take all of the air out of a perfect balloon, the surface itself would go to zero. All the dots would be back at one place at one time. Every place is the center of the expansion. When you talk about this, the question that always comes, well, can you find the center of the expansion? Every place is the center of the expansion. There is no center to the beginning. Everything was back at one place, and every place and every time was identical.
Without doubt, the universe has been expanding since the Big Bang. If there is less than a certain amount of matter in the universe, then the mutual gravitation of the receding galaxies will be insufficient to stop the expansion, and the universe will run away forever.
What if you threw a baseball up in the air and it never stopped? And then not only did it defy gravity, it started racing away faster and faster with nothing propelling it. That's exactly how astronomers felt in 1998, except instead of a ball, they found the entire universe was racing apart faster and faster by the instant. So why would the universe do that? Our best theory is that there's something invisible all around you, and even though you've never seen it, it makes up 70% of the universe. It's called dark energy.
The universe is created somehow from nothing 15 to 20 billion years ago and expands forever. The galaxies mutually receding until the last one disappears over our cosmic horizon. Then the galactic astronomers are out of business. The stars cool and die, matter itself decays, and the universe becomes a thin, cold haze of elementary particles. The death of the universe may seem a little depressing, but we may take some solace in the timescales involved. These events will take tens of billions of years or more. Human beings, or our descendants, whoever they might be, can do a great deal of good in tens of billions of years before the cosmos dies.
Einstein used to say that the most incomprehensible thing about the universe is that it's comprehensible. It's an old riddle. What is there about the human mind that so resonates with the rest of the universe that we're able to understand anything about the workings of nature on the largest scale? It's a philosophical question, I suppose, but science has been able to provide us with a little bit of the answer. When we look at subatomic particles and when we look at the stars and galaxies, we see evidence from every direction that the universe is all of a piece and that it began as a single seed smaller than an atom. And in a very real sense, you and I were there. Every scrap of matter and energy in our blood and bones and in the synapses of our thoughts can trace its lineage back to the origin of the universe. The natural laws that fragmented and multiplied as the young universe expanded and cooled continue to operate today in the beating of our hearts as well as in the trajectories of the stars. As the Quran puts it, the universe is as close as the veins in our necks. The evolution of the universe goes on not just around us, but within us. Our thoughts and feelings, after all, are part of the universe too. And its story is our story as well.